Hello everyone, I am Dr. Annalakshmi, Associate Professor, ECE Department, S.A. Engineering College. This is our vision and mission of the institute as well as the department. So in this series we are going to discuss about the GATE syllabus in the section 2, the networks, signals and system. In the network analysis, so in the first we have the circuit analysis. In the circuit analysis we have node, mesh, then the Thevenin's theorem, Norton's theorem, reciprocity theorem, all these things for the RL circuit, RLC circuit and the RC circuit. Similarly, for the continuous time signals, we are going to discuss about the Fourier series, Fourier transform, sampling theorem as well as its application. Then for discrete time signal, we are going to discuss about the DTFT, DFT, Z transform, then the properties of LTI system, all these things. So in this first series, we are going to discuss about the mesh analysis as well as the nodal analysis. So first we discuss what is the mesh analysis. Mesh analysis is used on the circuits to obtain the multiple KVL. KVL means Kirchhoff voltage law equations which are used to solve for the voltage and current in a circuit. Then it is also called as mesh current method. Then the following steps to be followed when we apply the mesh analysis. So in the first step we have to identify the mesh loops. Then in the second step the currents around these loops are taken to be the mesh currents. Then in the third step we have to use the Ohm's law to write the Kirchhoff voltage law, to write the KVL equation around each loop in terms of the mesh currents. Then in the step 4 we have to solve these equations in order to determine the mesh currents. Then in the step 5 we can find any desired circuit parameter from this mesh currents. So these are the steps to be followed in order to find the mesh. So before going for the nodal analysis, we have to know what is a supermesh. So supermesh results when two mesh have a dependent or independent current source in a common, that is between the two mesh. If we have any independent source or current source, then it is called a supermesh. So the properties of supermesh are, a supermesh has no current of its own because it should have the independent or dependent current source between the two meshes. Then a supermesh requires the application of both the KVL as well as the KCL. Usually for the mesh we will be having only the KVL alone, but if you go for the supermesh, then we need both the KCL as well as the KVL equation. Then the notable point is for the mesh analysis we need only the KVL and Ohm's law. Then what is a nodal analysis? The nodal analysis is used on the circuit to obtain the multiple KCL, whereas in the mesh analysis we have found the KVL equation, but here we find the KCL equations which are used to solve for voltage and current in the circuit. It is also known as node voltage method. Then the number of KCL equations required should be one less than the number of nodes that a circuit has, because we will take, if you have 3 nodes, then we will consider only 2 nodes, because the third node usually it will be taken as a reference node because it is called a ground node. Usually the ground node will be kept at a potential of 0, so the one node should be taken as a reference node. So the following steps to be followed when we apply the nodal analysis. First we have to identify the step 1 is identify the independent nodes. Then we have to, similarly in that time itself we have to assign the reference node. Then the voltage at these nodes are taken to be the node voltage. Then in the step 3 we have to use the Ohm's law in order to write the KCL at independent node in terms of the node voltages. Then in step 4 solve these equations to determine the node voltages. Then any desired circuit parameter can be determined from the node voltages. So this is the nodal analysis. Similarly, we have to see what is the supernode. A supernode is formed by enclosing a dependent or independent voltage source connected between two non-references node, because the reference node is a ground node. So if you have any independent source or dependent source between two nodes, then that is considered to be a supernode. Then the properties of the supernode. The supernode has no voltage of its own. Then a super node requires the application of both the KCL as well as KVL. The notable point for the nodal analysis is it requires KCL plus the Ohm's law. Then, what is the difference between the nodal analysis and mesh analysis, so that we can come to the clear analysis of the mesh as well as the node. So, in the mesh analysis, it is an application of Kirchhoff voltage law which is used for calculating the current. I have highlighted the what is the difference here for the mesh analysis as well as the nodal analysis. In the nodal analysis, it is an application of Kirchhoff current law, whereas here it is Kirchhoff voltage law, which is used for calculating the voltages at each node in the equation. Next, it is very simpler when there are more meshes than or when there are current sources, more meshes than the nodes, or when there are current sources or dependent sources that are not in parallel with the resistor. Similarly, in the nodal analysis, it is very simpler when there are more nodes. Here there are more meshes than the meshes, or when there are voltage sources or dependent sources that are not in series with the resistor. So this is the basics of nodal and mesh analysis. Now we will see the example problem in the mesh analysis. So this is the example problem in order to solve the mesh current. So the aim of this problem is we have to find out the I1 current and I2 current. Here the problem given is 2 with 3 sources. So we have 2 current sources, 5 amps and 4 amps with the voltage source 29 volts. Usually in order to find out the mesh current analysis, we need all the source should be in the voltage source. But the gate problem usually they will not give it in the direct form. So we have to find it in order to get the original circuit itself. We have to go for the using some tricks. So here we have to convert this two current sources into voltage sources so that we can apply the mesh analysis. So how to convert the current sources? 2 current sources we have. In order to convert this current source into voltage source, here we have the 2 steps. That is, in order to convert the first current source, V is equal to, the formula is V is equal to I into R. Here the current is given and the corresponding resistance value is given. If usually the current source will come across or the parallel with the resistance, voltage source will be in series with the resistance. So the current source, the current is 5 amps, the resistance is 3 amps. So totally the voltage will be equal to 15 volts. So here we have converted this current source into the voltage source. Similarly, we have to convert the second current source into voltage source. So the second current source is with the current of 4 amps and with the resistance of 3 ohms. So we will get the 12 volt as a voltage. Now we have to go for the modified circuit. So this is the actual circuit or the modified circuit from the problem given. So here we have converted this current source into voltage source. So what is the voltage? First voltage, it is 15 volt with the resistance of 3 ohms. But here the notable point is we should not draw the resistance in parallel with the voltage source. Here, so we have to draw the resistance in series with the voltage. So this is the basic rules. So the first source is 15 volt. So 15 volts we have drawn with the voltage source of, then the resistance is in series with that, then the 2 ohm resistance is as such it is drawn, the middle resistance is also as such it is drawn. Then here we have second source we have converted as a voltage source with 12 volt. So here the 12 volt supply is given according to the current conventional direction. Here this is minus and plus, and with the same resistance now it is in parallel with that. Here it is parallel, but now as per the rules, for the voltage source it should be in series. So here we have converted this current source into the voltage source. The remaining all these things it is as such it is drawn. So this is the modified circuit from the problem given. So next we have to go for the analysis of mesh analysis. Yes, so here this is the mesh analysis. So here we have to find out the I1 current and I2 current. We have to identify how many meshes are there. Here we have 2 loops. How many loops are there? here we have two loops. So this is the closed loop and this is the another closed loop. So in this closed loop we have one voltage source that is called 15 volt. So for this, in the step 2 we have to apply the KVL, Kirchhoff voltage law, for the first loop. So the total voltage source is 15 volt, which is equal to, we have a voltage across the two series resistance and 1 ohm resistance. So since it is both are in series, I have taken it as a 5 ohms. Then the current which is flowing through this is I1 current, plus this is the center resistance. It has the current of I1 as well as I2. When we consider the loop 1, we have to take the I1 current first. Since it is a second loop, it is not a reference loop, so we have to take it as a I2. The currents are in opposite direction, so we are going for the minus here. So if you solve this equation, we will be getting the 15 is equal to this equation 1. Then again we have to go for the KVL for the loop 2. Similar for the loop 2, but here we have a two voltage sources. One is 12 volt, another one is 29 volt. So here you have to see the direction of this. It is minus plus minus plus. So it is in series. So we have to add the plus 12 volt and 29 volt here. So here we have a 12 volt plus 29. So if you write the equation for this, then it is 3 ohms into the current I2 it is given. Then the current through this 1 ohm is only the I2 current, so it is I1 1 into I2. Then the current through the 1 ohm is I2 minus I1, because this is the reference loop now, so it is I2 minus I1. So if you solve these equations, then we will be getting this equation 2. So by using this equation 1 and 2, now we have to write the insertion method equation. So this matrix is nothing but this is finding the del value. So del value is equal to the resistance matrix into the current matrix, which is equal to the voltage matrix. This is a normal KVL method. Yes. So here the coefficients are written from the first equation. From the first equation, the coefficient of the I1 is 6 and minus 1. 6 and minus 1. Similarly, from the second equation, 5 and minus 1. I1 value is minus 1, so it is first written, then it is 5. Then the current which are used here is two loops, I1 and I2 it is written. The source voltage 15 and 41 it is written. So this is forming the matrix. So if you find the del value, determined value for this, then it will be equal to 29. Then if you wanted to find this, so this is the del value. If you wanted to find out the del 1 value, then we have to replace the first column of the del value with the voltage source what it is given. So here we have considered this matrix for the del 1, but we have replaced this one, that is 15 and 41, in the first column. The second column it is as such it is written. So if you find the value, then it will come around 116 for this. So how to find out the I1 means, the formula is del 1 minus del 1 divided by del. So what is the del 1 value? This is the del 1 value, this is the del value. So if you find the current of this, then it will become around the 4 amps. Similarly, we have to find out for del 2. So for the del 2, we have to replace that del value with the second column. So the second column now 5 and minus 1 has been changed as a 15 and 41. So if you find this, if you find the value for this, then you will be getting around 261. So how to find out the I2 means del 2 divided by del, which will give around 9 amps. So we have found finally we have found the I1 value and I2 value. So I1 value is 4 amps, I2 value is 9 amps. Thank you so much. In the next session we can see about the nodal analysis.